Hi, I am Priyansu. I am going to present my allotted paper. Here the paper is Interval Temporal Random Forest with an application to COVID-19 diagnosis. The team name is Prialgo Proves and the team member myself Priyansu and Rubul Gugoi. Now we go to the next slide. Here we have already read about the paper and we found that these topics are used in our our paper. The and we also present this presentation about these topics. The first topic is multivariate time series, decision tree, random forest, temporal decision tree, entropy, sound base, and the background. And what are the my next talks? Now we go to the multivariate time series. A multivariate time series has more than one time series variable. Each variable depends not only on its past, but also some dependency on other variable. This dependency is used for forecasting future value. For more understanding, let an example of dataset which includes perspiration percentage, dew point, wind speed, cloud cover percent. From the table we see that the from we see that the time is time is 5 a.m. to 5 a.m. to 1 p.m. and the temperature we see that the when the time is between the temperature also increases and sometimes it decreases. And as it is with the cloud cover, dew point, humidity, winds, these are the increasing and decreasing. Now we go to the decision tree. Decision tree is a non-parametric supervised learning algorithm. It has a hierarchical tree structure consist of root node, decision tree, branches, internal nodes, and the leaf nodes, and also the sub branches. Decision nodes is the basically we for using basically for decision tree, we present the data set in a T format. Now the here is the steps of the presentation in T format. First of the root node. Here's the starting point of the tree. It is not present at the beginning of a decision tree for from these nodes. And the second after root node we split the decision nodes. Now we go to the leaf node is the last instance where we cannot split the data sets. Now for more understanding we take the data sets. We take the example of the data sets. Here is the example of the weather condition, and we see that in this table, outlook, temperature, humidity, and wind are the predictors, and the plague will be the target variable, which is dependent on the predictor. Now here we where we make the decision tree. Outlook after Outlook is a root node. We split in decision nodes: sunny, overcast, and rainy. If Outlook is sunny, then we further again split in the windy. If windy, then we again split the false and the true. If false, then the play the gale, play the gale. Otherwise, no. Now it's also see that the rainy and split humidity high normal. Now now we go to the now we go to the random forests. Random forest is also machine learning algorithm based on the supervised learning that can be used for path regression and the classification problems. It consists random forest is a collection of the decision tree. Here is the some steps of the random forest. First of the step to create the first of the we split the data sets. Now the second step is we make the decision trees. We make the decision tree, and the finally step three we take the high majority of the value of the output, high majority of the value. Now for more understanding we take an example. Here we take the example of the collection of the food. From this example, we see that we split the tree one, tree one, tree two, tree n. Then from tree one, we find the apple class A, and the tree two also find apple class A, and the tree n give the bananas of class two. Then based on this output, we find that the apple has more majority than the banana. Then the final output is the banana. The final output, sorry, banana output, final output is the apple. Now we go to the application of the random forest. Here is application of in three right application: classification, regression, anomaly detection. Classification, we classified the data sets. And regression, in regression we find we show that there is no interaction between the one decision tree to another decision tree. Now the anomaly detection. The anomaly detection is technique to identify rare events, usual and a pattern unexpected value or deviation from the normal, or detecting errors or abnormality. Actually, from anomaly detection, we find the what are the data points we give the these types of error. Now the next part explained by Rubul Gogoi.
Hello sir, my name is Rubul. So as Pianso explained, when we represent our data in tree-like structures, they are called decision trees. So when we introduce a temporal dimension in it, they are called temporal decision trees. So the key difference between temporal and traditional decision trees is that in temporal decision trees, nodes can also represent splits based on temporal criteria such as time intervals or sequences of events. So they can capture sequential patterns in the data, and this is particularly useful for tasks where the order of events matters, such as in finance, stock prediction, etc. So whenever we use decision trees, we have to organize the features from the root nodes to the leaf nodes. So in order to do that efficiently, we use entropy and information based learning. So in machine learning, what entropy does is that it measures the level of disorder or uncertainty. So if we get a higher entropy value, it indicates a more heterogeneous data set, and if we get a lower entropy value, it indicates a more homogeneous data set. So we can calculate the entropy value at a particular node by using this formula. So I'd like to explain that with an example. So we have two coffee flavors, caramel latte and cappuccino. Uh, in case one, we have 7 caramel latte and 3 cappuccino. So in order to calculate the entropy value at the coffee flavor node, we have to calculate these terms. At first, we would calculate the probability of getting caramel out of these 10 coffee flavor pouches. It comes out to be 0.7 since there are 7 caramel latte out of the 10 flavors, out of the 10 pouches. And then we have to multiply it with log 0.7 with base 2. And then we would again do that for cappuccino. Its probability would be 0.3, and then multiply it with log 0.3 with base 2, and then add both of these terms and take negative of the resulted term. So it comes out to be 0.8. So this value shows the measurement of uncertainty, how much we are uncertain to get that we are not certain which flavor we would get when we pick up a flavor. After that, in case 2, we have 5 caramel latte and 5 cappuccino. So here entropy value is the highest, that is here the measurement of uncertainty is the highest, which is 1. In case 3, we have 10 caramel latte and 0 cappuccino. So here we are certain to get a caramel latte when we pick a flavor. So it's the level of uncertainty, so there is no level of uncertainty, so its entropy value is 0. So information based learning is also same as entropy based learning, but the main difference is that in entropy based learning we calculate the entropy value at a particular node, but in information based learning we calculate the entropy for each variable and its potential splits, that is across all the nodes. So here's an example. We have three nodes, f1, f2 and f3. Here f1 is the parent node, and these two are the children nodes. So we can calculate it by using this formula. So at first we would calculate the entropy value at the particular nodes. So for each one, f1 it's 0.94 and then so on. So the information gain at the node f1 would be first we have to take the entropy value of the parent node, and then minus number of elements in the child node divided by total number of elements in the parent node, and then we have to multiply it with the entropy value of the child node. So we would do that again for F3 node. So it, after substituting the terms, it comes out to be 0.049. So in case of an information based learning, we would like to have the information gain to be higher, and in entropy based learning, higher the entropy value, it's bad. So in our paper, cough and breath sounds are used in order to diagnose COVID-19. So this process is called sound-based diagnosis. So in medical context, sound-based diagnosis involves listening to specific sounds produced by the body in order to detect abnormalities or diagnose certain conditions. So in order to do that, we have to represent the spectral characteristics of sound in a way that is well suited for various machine learning tasks. So this is done by using mel frequency substrate coefficients. So these coefficients emphasize features of the audio signal that are important for human speech perception while discarding less relevant information. So this is done by this process. So at first we have pre-emphasis. So this step boosts the high frequency components of the signal in order to balance the frequency spectrum, and then we have framing the signal. So here the audio signal is divided into short frames in order to analyze the sound over time, and then we apply a window function because of the fourth step in order to reduce spectral leakage. So what happens is that when the fast Fourier transform is applied, then the frequency gets a little bit damaged. So in order to reduce that, we apply a window function. So the Fourier transform is applied in order to convert the signal from the time domain to the frequency domain. And then we have Mel filtering. So here the frequency spectrum is divided into several frequency bands using Mel filters, which are spaced according to the Mel scale. And then we apply logarithm. Here the logarithm of the energy in each Mel filter bank is computed in order to mimic a human auditory system's response to different frequencies. And then the discrete cosine transform is applied to the log filter bank energies in order to decorrelate the features and extract the most important ones. And then we keep the first few coefficients which contain the most relevant information about the audio signal. And then these coefficients are used for various audio processing tasks. So after that, we have uh, we have the references used. We have the references used for studying our material, and from here on, Priyanshu will continue.
Now, for this presentation, we refer the content from these sites. Multivariate time series, we take the analytic random forest, we take the gigs per gig decision tools. Also, we take the medium, and FCC, we take this analytical vidya, and these are the we take the slides and we take the content of these links. Now, we have searched the many times for the correct data set, but we cannot able to find the correct data set. Here is find the data sets. The data contains the day, corona and corona type, and the age, gender, medical, and the smoker present cough file. But in this data set, not include the breath columns. That's why it is not corrected, but it is fine. That's why we keep them. And for the correct data set, for the direct, for the correct data sets, we have already mailed the researcher of this paper, which is already work on the this type of data. And now we, after finding the data, we data cleaning, and we implement the algorithm. We implement the algorithm one and algorithm two. For this project, we use the Google Notebook or Jupyter, and the Python library, NumPy, Lambda, and Matplotlib. The coding part, we use the scikit-learn. Now, now the stops. Thank you.